Hey, good morning. So I apologize again if you're watching this because I'm out this afternoon, but it should just build on what we were doing yesterday. Um, so before we dive into that, I want to make sure we understand a couple things. So like terms should sound familiar, meaning you're kind of looking for terms that have the same variable. And if there are exponents, not only would it have to be the same variable, but the exponents would have to match too. But we're not even going to talk about exponents today. And when I say same variable, that could mean there's no variable. So for example, some like terms would be like 9 and -6. Those would be like terms. 7x and 2x. Those would be like terms. So two terms, no variables, two terms with the same variable, and that's all we're getting at. And so when somebody says simplify, it turns out that we can do operations like adding and subtracting. So, for example, (7x plus 2x) could be combined to say we actually have 9x. That would be an example of simplifying. So it's saying if you have 7x's plus 2 more x's, why write them separately when we could say we just have 9x's? All right. Here is my suggestion. So here's example 1. You'll notice there's 2 x's and 2 non-x's. Some of you might skip this step. Others might find it useful. It can be really helpful to group terms. So instead of having 7x and -2x separate from each other, as long as you keep the operation, we can rearrange these terms. And it makes it a little bit more obvious that we have 7x's, but we're taking away 2x's, and so we really have 5x's. And we have a +9 plus 11, and so we really have 20 non-x's there. This has an x, this doesn't. They're not like terms, and so this is as simple as it's going to get. That's it. All right. Now, something like this, remember if there's a number outside parentheses, that should clue you in that you're going to have to distribute. So, in other words, remember that 5 outside parentheses really tells you that you're multiplying, and you're going to multiply with both terms inside. And so 5 times 3x is going to be, we really have 15x's total. And then we have 5 2's, and so that's really 10 total. Once again, I have an x and a non-x, and I'm done. That's as simple as it's going to get. All right, if we take a look at example 3 here, this is kind of combining everything. And so now we have to worry about our operations. So remember, the first thing I want to do, can I simplify what's inside parentheses? Well, this has an x and this doesn't, so there's no way I can simplify what's inside. And so now I can think about that 2. So that 2 is going to get distributed in. And so now I'm going to have a 16x because I have 2 8x's. I have 2 7's, so that's 14 total. And now I have the 5x and the -10 still because I didn't do anything with them. All right. So once again, if you notice, the x's are separate, the non-x's, and so I can group just like I did above. And now I would have 16x and a +5x, +14 and a -10. So not a mandatory step, but it can be really helpful when it comes to avoiding mistakes combining. Now 16x and 5x is going to be 21x's total, and this +14 -10 is going to leave us with just 4. And there we have that one. Then finally, this is where things get tricky when I have a bunch of negatives showing up. So once again, I'm checking my parentheses, can't combine anything inside, and so now I'm going to think about multiplying. It's convenient to think there's just a 2 in front, but notice how there's a minus in front of that. So we're going to treat it like a negative. So when I see that -2 outside, I'm thinking, what's -2 times 4x, and what's -2 times -8? So when I have that subtraction, I'm really thinking of them as negatives when I'm performing my operation. So -2 times 4x is really -8x. And -2 times -8 is really +16. And so now I've dealt with my multiplication. I'm just going to write down the terms that are left. So I didn't do anything to that 10x, and I didn't do anything to that 12. So they get to stick around just like they were. All right, and now you're going to notice that everything is already grouped. And so I'm good to say, what's 10x minus 8x? That's 2x. What's +16 minus 12? That's going to be +4. And that's going to be my final expression. All right, and then finally, I want to talk about what it means for expressions to be equivalent. So just because expressions don't look the same doesn't mean that they aren't actually the same, because if we simplify, that might reveal something. So I'm going to say, let's simplify this to start. I have 30x plus 22 minus 12x, and so I'm going to group my terms again. Don't forget your x. And now I can see 30x minus 12x is going to be 18x plus 22. Now I'm going to simplify this one. I have 2 times 9x and 2 times 11. And sure enough, you'll notice that that's going to become 18x plus 22. And so these are equivalent expressions because even though they look different initially, notice how they both simplify to the same exact thing. So simplification actually helps us identify when things are really the same or when they're different. All right, so on today's assignment, you're going to notice some questions that kind of ask you to think deeply. So like if two expressions are really equivalent, think about what they might evaluate to. But you'll have a chance to think about that. I will be reviewing some of these ideas in class on Monday, so if you do get a little bit stuck, just let me know, and I'll make sure to hit upon those points. All right, otherwise, good luck, and I will talk to you Monday.